Welcome everyone. In this lesson, we're going to see how to find the intervals of increase and the intervals of decrease for a function. So this is probably one of my favorite topics here. This is a fun one. So it's got derivatives, it's got simplifying derivatives, it's got sign charts, it's got it all. All right, so let's see. We've probably seen some of these definitions and results before, but now we're just kind of putting them together. So how do we actually find the intervals of increase or decrease for a function? Well, we have this test, which says if we have, where'd we go? There we go. If we have this interval from a to b, if the derivative is positive on that interval, then f is increasing on that interval. If the derivative is negative, well then the function is decreasing on that interval. And that's really the big result here. We've kind of talked a little bit about this before, but if f prime is positive on that interval, then f is increasing. And if f prime is negative, well then f is decreasing. Why is this plausible? Well, if f prime is positive, that means the slope of the tangent lines are all pointing up like that. And so your function's increasing. If f prime is negative, well then the slopes of the tangent lines are all pointing down like that. And so your function, your graph must be decreasing. Very plausible here. All right, so how do we actually do this? Well, since we're going to be interested in where f prime is either positive or negative, that means we need f prime. So first step is calculate the derivative, and along with that, we need to simplify it. We're going to need to simplify our derivative normally. Most of the functions we'll have to simplify. You know, whether that's factor, get a common denominator, things like that. All right, so that's the first thing. Get our derivative. Then the next step is figure out where the derivative is equal to 0 and where the derivative is undefined. So as these lessons go on, you're going to notice a theme. And the theme is differentiate, figure out where the derivative is 0 and undefined. That's going to be something we do a whole bunch in these lessons. So that's our first step. Get the derivative. Second step, figure out where that derivative is 0 and where it's undefined. Then we're going to do a sign chart for f prime. And so these places where our derivative is 0 and these places where the derivative is undefined, what those are going to do is they're going to kind of slice up our number line and give us the potential intervals. And then what we're doing with the sign chart is we're checking, okay, on those intervals, is f prime going to be positive or negative? And then we're actually going to use the sign of f prime on each of those intervals then to make this determination. So if f prime is positive, well then f is going to be increasing. If f prime is negative, well then f is going to be decreasing. And so how we're actually going to determine the sign of f prime is we're going to use test numbers. And what we're going to do is we're going to figure out a test number for each interval, and we're just going to plug it into f prime and see if we get a positive result or a negative result. All right. Now, one little note here about the intervals of increase and decrease, and in particularly, we're finding where the derivative is 0, we're finding where the derivative is undefined. Now, we've seen the definition for critical numbers, and there's kind of one extra condition here for a critical number, and that's it needs to be in the domain of our function. Now, for the intervals of increase, decrease, we're not entirely interested in that. We just want to know where is the derivative 0 and where is the derivative undefined. So there's a slight distinction here. So when we do our sign charts, we're going to, and we plot our critical numbers, we're going to use a filled in circle to denote a critical number, and we're going to use an open circle to denote a non-critical number. So these places where f prime is 0 and places where f prime does not exist are going to be important regardless, because our sign of f prime can change there. But it doesn't necessarily mean that it's a critical number. If it's not in the domain, it's not a critical number. So just a little note here. So our critical number, for it to be called a critical number, this is kind of just more of a semantics type definition here, but there is some weight behind it. So when we're finding these places where the derivative is 0 and where the derivative is undefined, those are potential critical numbers, but there's one extra condition. And so for it to be truly a critical number, it has to meet one of those conditions, but it also has to be in the domain of our function. But for the purposes of finding intervals of increase-decrease, we're actually not really entirely interested in whether it's in the domain. So we're interested in whether our function is, the derivative is 0 there, or derivative is undefined. All right, so just something to keep in mind. But the process we're going to go through is find the derivative, figure out where it's 0, where it's undefined, create a sign chart for f prime, and then actually go through and fill in what the sign chart is using test numbers. So we'll see that in an example.